Well, we have 7 people out tonight. Which is the reason I'm recording. I'm hoping that I can get away without having to have 7 separate meetings with 7 people, which I'll do this. What I get paid to do. But I'll videotape the class. I always try to do that. I have most of the class already from previous terms on video, so if you have to miss, we can do that. I usually then put it on thumb drives. I ask you to bring a thumb drive if you have one. I do have some, but they tend to, get lost or not turned back into me, and they're my personal ones. So if you ever have to miss, we can do that. The ones that are, I have all the class except tonight's session. Tonight's the only one I didn't have banked up, so we have to do that one over again. So if you would like to, if you'd like to have a copy of it after class, if you think, gee, I'd like to see that again, like I said, if you have a flash drive, a thumb drive, if you want to bring it to me, it has to be, because it's a video file, it has to be at least a 4 gig for me to put it on there, because a 2 gig won't be big enough. But if you have one of those and you'd like to have the class anytime, just let me know and then you can watch it again. But tonight I'm gonna get tonight. Tonight I have good news and bad news. Which do you want first? Bad news. Make sure it's recording. Yes, it is. Bad news. Tonight we do the hardest math we do all term. Want the good news? Tonight we do the hardest math we do all term. Hey! So if you get through tonight, you're okay. All right. So tonight is the math night. So we only have one concept to learn tonight, but it is the most complex mathematical operation that we will do. So we only do one, focus in on it, try to figure out what it is and why we're doing it and why we want to care about it and what it's actually accomplishing. Just focus in on that one. So we won't be here an awfully long time tonight, probably be here for about another hour, but we really want to make sure you understand this concept because it's really a powerful statistical concept. And to start out with the idea of what we're doing, suppose I decided to mow lawns on Saturdays to make some money, assuming there's going to be grass this year, but let's assume I decide to do that. And let's say that week 1, I make $100. Not bad for a Saturday mowing lawns, right? And then let's say week 2, I go out and I make $2 because everybody saw me mow the lawn the first weekend. So one little old lady gives me $2 to get off the porch. What's my mean? 51. It's 102 divided by 2, so my mean is 51, right? Okay. All right, suppose instead week 1 I made $50 and week 2 I made $52. What's my mean? 51, right? 102 divided by 2, 51. So in both cases, the mean is 51. Mathematically accurate, 51. But if this is the true data set, okay, do you think 51 is a good predictor of what I'm going to do next week?
No.
Do you think the 51 is a good representative of this data set?
No.
Okay, how about over here? Is the 51 a good representative of this data set?
Yes.
Do you think the 51 is a good predictor of what I'll do next week?
No. Well, yeah.
Okay, now come on. In one setting you say 51 is good, and in the other setting you say 51 is bad. It's calculated the same way. What's the difference?
The spread.
The spread, okay? The data, the spread of the data. So what we need to look at is the spread of the data. People are going to walk up to you and they're going to give you the mean. And you're not going to get to see the actual data behind it most of the time. And so you have to figure out, can I trust this mean? Now, one of the things you can do is ask them for the median. That gives you some help. But to know whether or not that mean is really trustworthy, it'd be great if you had an idea of the spread. So we need to come up with, we need a single value that measures the spread of the data. if the data is all spread out, right? The mean is not reliable. I can't trust it. If the data is all spread out, the mean is not reliable. So I need a single value to represent that spread. And I'd like it to be represented in such a way that if it's a big number, that means the data is all spread out. And if it's a small number, that means the data is compact. Okay? So just like in the stem and leaf plot, I had you look at whether the data was spread out or the data was compact. Now we're going to measure it. And the honest truth is, you know, we did that stem and leaf plot. Almost everything we do from now on is confirming or testing that exploratory analysis. We asked you what a typical value was, then we found the mean, median, mode, right? We asked you if the spread was compact or dispersed, compact or dispersed, right? Now we're going to measure it. So we're going to come back and confirm that analysis. So I want a single value that will measure the spread. If the data is all spread out, the mean is not reliable. So I'd like to have whatever this guy is be a big number. So if he's big, I know the data is spread out. If he's small, I know the data is compact. Now, there are many different ways to measure the spread, just like there was mean, median, mode to measure center, right, to measure a typical value or summary value. We're only going to look at one, though, the most common, and that's the standard deviation. Standard deviation. Okay? Standard, another word for that is average. And deviation is distance from the mean. So the standard deviation is measuring the average distance from the mean. Standard deviation is measuring the average distance from the mean. I saw you shaking it. Just in case. Okay.
Thank you very much.
Standard deviation is the average distance from the mean. Okay? So if this is a big number, so if the standard deviation is large, that's telling me the data is spread out. So the mean is not reliable. So that's why we care about the standard deviation. If the standard deviation is a large number, that's telling me the data is all spread out. And you can't really trust that mean. That's what it's telling you, okay? So it's measuring the average distance from the mean, okay? On average, how far away are the data points? Now, it is, as I said, an ugly mathematical formula, okay? So, let me move this thing and I'll go over to this side. I don't know if I can see that far or not with this guy. We'll see if I can. We'll move to the other side. So I have plenty of room to write this big honking formula. Oh, people who are watching this are going to go get dizzy. There you go. Ooh, let's see if we got the, not quite. Here we go. See if we can zoom in a little bit more. Oh, other way. There we go. Okay. Here comes the formula. You ready? We use a very harmless little s, baby s, okay, to be non-threatening. Deep breaths. Take deep breaths and don't go running from the room.
Is that a parenthesis?
Parentheses around xi minus x bar. Yes. Okay, now, don't be upset. We're going to be okay. Remember, what we're looking for is the average distance from the mean. That's what we're looking for. If you remember what you're doing, what you're trying to do, the formula will start to make sense. Average distance from the mean. So what's this x with a bar over it? That's the mean, right? Now here's the thing about math. You always have to start from the inside and work your way out, from the most complex and work your way out. So we're going to start with that. So step 1, find the mean. You can do that, right? Is that this? Okay, so find the mean. Now remember, step 1 is find the mean. So remember, we're looking for the average distance from the mean, right? So step 2, this xi means individual observations. So since we're looking for the average distance from the mean, what we do is we take each observation and we subtract the mean out of it to see how far away it is, okay? So step 2 is subtract. I can't spell. Good thing I'm not in English. Subtract the mean from each observation. So I can find out how far away they are. Okay, so we're looking for the average distance from the mean. So we found the mean and we subtracted it from each observation, so we have these distances. Now normally, when we want an average, we want the average distance from the mean. So normally when we want an average, what do? Add them all up and divide by the number. But we have a problem. The mean is hopefully right in the middle, correct? And there are numbers that are bigger than the mean and numbers that are smaller than the mean, right? So if we have a number that's bigger than the mean and we take the mean out of it, we're left with a nice positive number, right? But what happens if we have a number that's smaller than the mean and we subtract the mean from it? What do we get? Negative. So we're getting positive numbers and negative numbers, right? Big positives, big negatives. Little by little bit. Make you smile yet. Okay? So if I have positives and negatives, when I add them all together, what do? Cancel each other out. So I can't just add them together. I have to get rid of those negative sides. And that's what this guy does. He squares them. So step 3, square the answers found in step 2. Square them. Now, everybody look at your calculator. This is the hardest part of getting this right, is figuring out how to use your calculator. Okay? So you got to figure out how to use the calculator. Some of you on your calculator will have a little button that looks like this, an X with a 2. Squaring means to multiply the number times itself, okay? So if you have that little button, you want to learn to use it. So on your calculator, you can do like 6 minus 9, and you'll get negative 3. And then just hit that little square button, and it should say positive 9, okay? Now, if you don't have that little button, anybody not have that little button? You can say 6 minus 9 and get the negative 3, and then just hit times and equals if you don't have the little S squared button. Okay?
Say that again, 6 times 9.
6 minus 9
6 minus
would give you the negative 3, right? And then hit times and equals. Let's try it, see what you get. 6. Okay, good. So it did the square for you. Now here's the reason you want to do that. Because if you just put in your calculator negative 3, mine won't do it. Mine won't take just a negative 3. I can keep putting it in all day and it won't take it. It just won't do it. So your calculator is basically stupid. Okay? Well, it is. And it doesn't understand -3. Now, some people have on their calculator a plus minus button that will let them hit that and then hit -3. But it's really a lot easier if you just do steps 2 and 3 together, and I'll show you a way to do this. But you want to make sure you understand the square button. Only reason we're doing the squaring is to get rid of the negative sign. A negative number times itself is a positive number. So -3 times -3 is +9. Don't ask me why the math gods made it that way. Okay? The math gods, I think they're pagan. Okay? They must be. Okay? Okay, so everybody know how to square? Okay, so what we've done is we've found the mean, we've subtracted it from each observation, and we've squared it to get rid of the negative sign. Now, what's this big E mean? Sum. So next, we sum. Step 4, add up the squared differences found in step 3. Basically, add them up. Add them all up. Okay? So we've done everything on this top part. We found the mean, subtracted it from each observation, squared them, and then added them up. Okay? So we've done all of that. Okay? What's this guy mean?
Divide.
Divide. So the next step, step 5, is to divide the answer found in step 4 by, divide the answer found in step 4 by n minus 1. Now normally, when we find an average, because we're looking for the average distance from the mean, right? Normally we add them all up and divide by what? The number of them, right? But here we add them all up and divide by the number of them minus 1. Now, I'm going to give you 2 explanations for this. I'm going to give you the statistical explanation and the movie explanation. Okay. Here's the statistical explanation. You can only use data equal to the number of, you can only use data the number of times you have equal to observations, or equal to the number of times you have observations. So if I have 10 observations, I can use that data 10 times. If I have 20 observations, I can use it 20 times. If I have 10 observations, I can't use it 20 times. That's the limit, okay? So we're limited to using the observations equal to the number of observations we have. So if I have 5 observations, I can only do 5 things with that. I can't do 25. If I have 100 observations, I can do 100 things. You see what we're saying? That way you keep, every time you use the data, you comb through the data. And so if you have very few observations, you can only use it a very few times. Okay, we've already used the data once in this formula to find what? The mean, right? We've already used the data once. So we're free to use it how many times? In however many we have minus 1, right? Because we already used it once. This is called the degrees of freedom. Freedom, oh freedom, yeah, freedom! All right, degrees of freedom. All right, now here's the movie definition. Life is like a box of chocolates. I've never seen that movie, but everybody says that's what it says. Movie about a runner. Is that what it's about? I've never seen it, but I know. Okay, you know those little boxes of Russell Stover's chocolates? They have 4 chocolates in them. They're now like $1.79. They used to be like 39 cents. That's how old I am. They have them at Hy-Vee. They make excellent bribes. I do accept all bribes. I just don't guarantee any results, but I do accept all bribes. Okay. Somebody's wearing a Dr. Pepper shirt tonight. Bing, bing, cool. Making points. Okay. So you know those 4 chocolates, right? 4 chocolates. Okay. Let's get this straight. I'm going to eat them all. Okay, there's no question. All right. So I go to the box and I make a choice. Be about that fast. How many chocolates left?
3.
3. I make a choice.
2.
Caramel.
Okay, I go back to the box. How many chocolates?
1.
2, right? 2. I make a choice.
Coconut.
See, I like the coconut. I don't like the one with the jelly inside. Ugh. Chocolate covered jelly. That didn't even. Okay. I go back to the box. How many chocolates?
1.
Do I have a choice?
No.
No. How many did I start with? 4. How many choices did I have?
3.
3. N minus 1. Why?
Elimination.
Because the last one was already, there was no choice with that. Okay, here's what we've done with this problem. We've taken all the data points, right? And we've calculated the mean and stuck it down. All right? And all the other data points fluctuate around that guy, but he's not free to move. He's not going to change. So as we go through all these data points, the mean is not free to fluctuate because we've already calculated him and used him in this data set. So how many of the observations are free? N minus 1, because the mean is already stuck down. Okay, all right? So we found the mean, we subtracted it from each observation, we squared, we added up, we divided by N minus 1. We've done everything inside here. What's this great big guy mean?
Square root.
Square root, step 6. Hit the square root button. Okay? Now again, everybody look at your calculators. For some of you, the square root will be a separate button. For some of you, it will be a secondary function. On my calculator, it's a secondary function. It's above the little x squared button. So what I have to do is hit second, I turned it on first, second square root, like the number 9, and equals is what I have to do, and it says 3. So figure out how to find square root on your calculator. Some of you just have a single button, some of you will have to do a secondary function. Everybody figure it out?
No.
No.
Where's my equals? This is my science.
Okay.
I did the square root.
Okay, you gotta do, well, I just do my calculator again. Okay, let's figure it out. Okay, we're gonna do second square root of 9, enter is your equals. See the 3 over
Oh,
there?
there it is. Thank
Okay.
you, Susie.
All right? But you have to do it in that order.
Square root 9 equals.
Yes.
Okay.
You have to, see how it looks like the little square root's over the 9? If you tried 9 and then second and then square root, it's weird. Okay, so don't.
Square root first.
That's because you have a separate button, right? See, we don't have that. See how ours is over?
Oh, okay.
It's over that button, so it's a secondary function. Everybody figure out how to find square root?
The answer moves over here. That is
Yes? Everybody got it? Easy peasy?
easy.
Let's try the problem. Let's try the problem.